the previous session, we looked at the linear regression line and its uses, but at the same time, we tried to come up with the types of the linear relationship, in which we said we talk about the negative linear relationship, the positive linear relationship, and the zero linear relationship. But remember, we said the linear regression line is actually presented, or you can actually come up with a linear regression equation which will describe that particular line, the line that is going to minimize the distances, the deviations, the sum of the deviations of those particular distances. So let's look at the linear regression equation. Linear regression equation. The linear regression equation. This one allows us to express the relationship between two variables algebraically. So allows us So this one allows us to express the linear regression. So the linear relationship algebraically. So it allows us to express the linear relationship algebraically. And when we do that, we can use that particular equation to predict for the values of the variable that we are trying to deal with, the variables that we are trying to deal with, if we are going to have x variable and the y variable. This particular equation, most of the times, the regression equation is written. So it is written in the form of y hat is equal to a plus bx. That's the linear regression equation. Now, what are these particular letters representing? The y hat is actually the value of the dependent variable. The value of the dependent variable which can actually be predicted in this particular equation. And then the A represents the y-intercept. The y-intercept. So y hat is the value of the dependent variable. The value of the dependent variable that can actually be predicted in that particular equation. Whereas the A is the y-intercept. That's the point where the line that we have drawn, the least squares regression line, is going to cross the y-axis. That's where we say the y-intercept, or it is given the value of A. B is actually the slope. The slope, or others prefer to call it gradient. Gradient. This one represents the change in y divided by the change in x. We say that's the gradient. So we are saying B is the slope or the gradient, and our duty in this particular work or regression, when we're trying to get the linear regression equation, is to find the values of A and B, because those lines which I mentioned will have different values of A and B. But which of the lines is going to have A and B that are going to bring the squares, the sum of the squares, to minimum as much as possible? The X is actually the independent variable. X is the independent variable. So X is the independent variable. So X is the independent variable, and we need to consider that. So our duty, as I said already, is to find the values of A and the value of B, such that when we fit them in this particular equation, they are going to bring the sum of the squares, the deviations from the point to the line, to minimum as much as possible. So to use the equation, for us to use this particular equation, first of all, we must calculate these particular values, or the values of A and B in that particular equation. Now, how do we calculate the values of A and B? Let's look at calculating A and B in the equation so that it brings these particular values minimum to minimum as much as possible. Our formula, the formula that we use to calculate the value of A is given as A is equal to Y bar, which is the mean of Y values, minus B, in which case the B is the same value that we talked about, the gradient, multiplied by B bar, X bar, which is the mean of X values. This one is actually coming from a little bit of calculus, which we are not covering in this particular course, but what you have to know is that A is calculated by finding the mean of the values of the dependent variable minus B multiplied by the mean of the values of the independent variable. Formula for finding B is given as, so it's given by B is going to be equal to the sum of values of the product of X and Y minus the sum of X multiplied by the sum of Y divided by N, where N in this particular case is the number of data pairs that we have in the data set. This thing here, you need to divide this by the sum of X squared minus the sum of X bracket squared divided by N. You will see that if we are trying to calculate these particular values, then we are going to get the values of B. Let me emphasize here that this one, we should take note that regression of Y on X is not the same as the regression of X on Y, because the other one will actually change. Instead of having this as a denominator, we are going to have the sum of Y minus the sum of X squared over N. That we must actually take note of. For convenience purposes, we can rewrite this one as B is equal to cov xy divided by variance of x. Cov xy divided by vx. So that's variance of the variance of x. The cov of xy is covariance. It's the covariance of x and y, and then the vx is actually the variance itself. So the numerator here is what we call the cov of xy, while the denominator, this one, is what we call the variance of x. So in short, we just write vx.